Hi everyone, this is Pre-Algebra Lesson 2-10, Operations with Numbers and Scientific Notation. In this last lesson of this topic, we will perform operations with numbers and scientific notation. You will be able to apply number properties to calculations with numbers and scientific notation. As a language objective, you should be able to explain how to perform operations with numbers and scientific notation. To start with, number properties can be applied to understand how to add, subtract, multiply, and divide numbers in scientific notation. Using scientific notation, we learned last lesson, how can we use operations with it? Let's look at solve and discuss it and get started with that. The homecoming committee wants to fly an aerial banner over the football game. The banner is 1,280 inches long and 780 inches tall. How many different ways can the area of the banner be expressed? So first of all, what do you need to know? First, yes, identify the important information. We got 1,280 inches long and 780 inches tall. Those are the width and the length. Those are the dimensions. Second, calculate the area. 1,280 times 780 would be your area, length times width. Okay. Third, you would put that answer into scientific notation. So let's first multiply the numbers so that we can calculate the areas. 1,280 times 780 is 998,400. Okay, and you will write this in scientific notation. 998,400. That's where we're starting from. That's your decimal point. 1, 2, 3, 4, 5. You move the decimal point back five places so that it's on your right of the first non-digit in your number. So that's going to be 9.984 times 10 to the 5th power. Okay. How many different ways can the area of the banner be expressed? Really? How many different ways? If you're writing it in scientific notation, this is the only way. But if we're talking about not just scientific notation, but in terms of powers of 10, you can also say 99.84 times 10 to the power of 4, right? Or 998.4 times 10 to the power of 3. Or maybe decimal places, 0.9984 times 10 to the 6th power, and so on. There are many, many ways to express the same number. But in terms of scientific notation, there is only one way. Okay, your first expression needs to be a digit less than 10 and more than or equal to 1. Okay. Let's look at focus on math practices. Which of the solutions is easiest to manipulate? Which of the notations over here is easiest to manipulate, to use it for different problems? Probably the scientific notation, but why? Because the numbers are more concise. And if you're comparing other numbers too, it really helps to have one notation that we all agree to. Let's write that down. Okay. So let's think about this big essential question throughout the lesson today. How does using scientific notation help when computing with very large or very small numbers? Think about how it should be helpful. Example 1, add or subtract numbers in scientific notation. The mass of Earth and the mass of the moon are shown. How much greater is the mass of Earth than that of the moon? Right? So Earth has about 5.97 times 10 to the 24th kilogram for mass. Moon mass is 7.35 times 10 to the 22 power kilograms, right? So what does the exponent tell you about the magnitude of the number? Which one is greater? Obviously, the bigger number is the greater one because we're multiplying. If we're multiplying it by 100 times more, then that would be greater, no matter what the first number is, right? So the Earth mass is going to be bigger, okay? So one way you can write masses in standard form and then subtract, right? There's a bunch of zeros in there, and that looks like it's going to be very dangerous because what if you forget to write a zero? What if you make a mistake? I feel like it's just really easy to make mistake with those big number with many, many zeros, okay? And then you can write your difference in scientific notation. Another way, you can write the masses using the same power of 10 and then subtract. You cannot subtract the numbers, the digits for the first expression when you have different powers. But if you have the same powers, you can, okay? So you will make the same power. How do you do that? Do you remember how we have different ways, multiple ways to express the same number like this, right? With different powers. You move the decimal places to and add and subtract the powers to represent the same number. That's what we're going to use, okay? We're going to use property of exponents to write 10 to the 24th power as 10 to the second power times 10 to the 22 power, right? Because if you multiply 10 with the same base to a different power, what does the property of exponents say? You can add the powers together. So 24 really could be written as 2 plus 22, right? So we're going to separate the power of 10 like this and group 5.97 with 10 to the second power together and say, oh, that's really 597 times 10 to the 22nd power. And now we have the same power. That means we can subtract the numbers. 597 minus 7.35 is going to be about 589.65. Remember, the first factor must be greater than or equal to 1 and less than 10 for scientific notation. So for your final answer, you still have to move your decimal places 2 places to the left. And that means you need to multiply 100 more, which goes to the power. You add 2 to the power, okay? So the difference is about 5.8965 times 10 to the 24 kilograms. Either way, you will get the same answer. It looks like the algebraic, the second way, seems like it has more steps, but with a big number like these, it is safer to use the second way. And if you get used to it, you will do it quickly, right? More quickly than writing all the zeros over there. So let's try this problem. The planet Venus is on average 2.5 times 10 to the 7 kilometers from Earth. That's the distance from Earth. The planet Mars is on average 2.25 times 10 to the 8 kilometers from Earth. When Venus, Earth, and Mars are aligned, like in the same row, in one row, what is the average distance from Venus to Mars? Okay, so that means if we have, so obviously Mars is a little bit further away, maybe a lot further away, but a little bit further away from the Earth, right? If this is the Earth, we got Venus and we got Mars over here on average, okay? When they are aligned, so Earth, Venus, Mars in one row. What's the average distance from Venus to Mars, right? We already know this distance, Earth to Mars, Earth to Venus. So what do we do with these numbers? We subtract them to get this distance, Venus to Mars, okay? So we are going to subtract them using scientific notation. In order to subtract the numbers, you have to make the powers the same. So you're going to change 2.25 times 10 to the 7th, 10 to the 8th power. So this is the Mars one. I think that's a typo. 10 to the 8th power, right? As you're going to rewrite that as, what do you need to do to make 8 7? You subtract 1. So you have 10 to the first power times 10 to the 7th power. And you can multiply 2.25 times 10. You have 22.5 times 10 to the 7th power. Okay? 2.5 times 10 to the 7th power plus 22.5 times 10 to the 7th power would be 2.5 plus 22.5 times 10 to the 7th power, okay, which is 25. And you can write that as 2.5 times 10 to the 8th power. I don't think this is true. Why? Because we didn't subtract it. Okay, so we're going to subtract. I don't think the textbook had a right link. So we're going to write 22.5 times 10 to the 7th power minus 2.5 times 10 to the 7th power is equal to 2.5 plus 20. Wait, I'm just copying that down. We're going to subtract, remember, 22.5 minus 2.5 times 10 to the 7th power. We have 20 times 10 to the 7th power. Write it in scientific notation, 2.0 times 10 to the 8th power. Okay? Convince me. In example 1, and try it. Why did you move the decimal point to get the final answer? Why? Because the first factor was greater than 10. The initial answer was not in scientific notation. Okay? Okay, moving on to example 2. Multiply numbers in scientific notation. The Confederation Bridge connects New Brunswick to Prince Edward Island. The main part of the bridge rests on piers that form 43 segments. What is the approximate length of the main part of the bridge? Express your answer in scientific notation. Okay, first step, write an expression to represent the problem situation. So this is the length of one segment, right? What's the approximate length of the main part of the bridge? They form 43 segments. So you're going to multiply this by 43. Okay? And so you can say, I'm going to write this in scientific notation because you have to express your answer in scientific notation. So you're going to start with scientific notation in the beginning as well. So what's 43 in scientific notation? Move the decimal place by 1 place, and then you multiply by 10, and that's equal to 43. Okay. Step 2, you multiply these two numbers. And then you will get your answer. But how do you multiply scientific notations? If you multiply 8.2 by 10 to the second power times 4.3 times 10 to the first power, they're all multiplication. What's the property of multiplication? The order doesn't matter. So you can group 8.2 and 4.3 together and multiply them. And you can group 10 squared times 10 to the first power together and use the product of powers property, combine the powers, add the powers, and that should be close to scientific notation, right? 8.2 times 4.3 should be 35.25. And 10 to the second power times 10 to the first power is 10 to the power of 2 plus 1. So you have 35.26 times 10 to the 10 cube. And so in order to write that as a scientific notation, move one decimal place and add 1 to your power by moving it. So your last answer, final answer is 3.526 times 10 to the fourth power. Okay, the length of the main part of the bridge is approximately 3.5 times 10 to the fourth feet. Example 3. Divide numbers in scientific notation. A queen ant lays 1.83 times 10 to the 6th power eggs over a period of 30 days. Assuming she lays the same number of eggs each day, about how many eggs does she lay in one day? Okay. Express your answer in scientific notation. Assuming she lays the same number of eggs each day. That's important. Okay. In real life, it's really hard to lay the same number of eggs each day, even in nature, because they're not robots, right? But we're assuming that she lays the same exact number of eggs each day. So we're going to multiply this number by 30 because that's for a period of 30 days, right? Oh, wait. That's total she had laid for 30 days. So you're going to divide that by 30. Okay. And so you're going to write both numbers in scientific notation. Got 3.0 times 10 to the first power. And dividing it means the first number divided by the second number. First number is the numerator. Second expression would be the denominator. And if you have a number over another number, what can you do to simplify the fraction? You can divide these two numbers together. You can divide these two numbers together and multiply them. 1.83 divided by 3 times 10 to the 6th power divided by 10 to the first power. What's the quotient property of powers for exponents? You can subtract the powers when they have the same base and they're divided, right? So you will have about 0.16 times 10 to the 6 minus 1. And is that in scientific notation? No. Move your decimal place to get your final answer, which is 6.1 times 10 to the fourth power. All right, the queen ant lays about 6.1 times 10 to the fourth eggs per day. That's a lot of eggs. Let's try this question, try it. There are 1 times 10 to the 14th good bacteria in the human body. There are 2.6 times 10 to the 18th good bacteria among the spectators in a soccer stadium. About how many spectators are in the stadium? Express your answer in scientific notation. So first, what's the important information? These numbers, 1 times 10 to the 14th bacteria, good bacteria. There are 2.6 times 10 to the 18th good bacteria in a soccer stadium. Okay, so about how many people are there? If you know how many good bacteria is for one person. you are going to divide the numbers, right? So you're going to divide the total number 2.6 times 10 to the 18th by 1 times 10 to the 14th power. And write it as a fraction to visualize what you're doing. And then you can group the numbers together. 2.6 divided by 1 is 2.6. And you have 10 to the 18th power over 10 to the 14th power. What's the quotient property? Quotient power property of exponents? Yes, you can subtract the powers when they're divided with the same base. So you have 2.6 times 10 to the power of 4. Is that in scientific notation? Yes, it is already in scientific notation. So you can just say 2.6 times 10 to the 4th power is spectators. That's your final answer. All right, that was lesson 2-10. Let's summarize the lesson. Operations with very large or very small numbers can be carried out more efficiently using scientific notation. Okay, the properties of exponents apply when carrying out operations. Remember the product of powers property. When you have the same base multiplied to each other, you can add the powers. Using that property backwards, you can separate one expression into two. Okay, using multiplication, you can use a product of powers property to combine the powers and simplify your notation. Using division, you can use quotient of powers property to subtract the powers when the same base is divided by each to itself, right? With different powers. Okay, so that was lesson 2-10, the last lesson of this topic. And it was about operations with numbers and scientific notation. All right, that was it for 2-10. In topic 2, we learned about real numbers. You should be able to categorize the different categories of real numbers and know how to express them in different ways using rational numbers and scientific notations, and use the properties of exponents to carry out the operations of big and small numbers as well. All right, thanks guys. See you later. Bye.